Hello, people, and welcome to VR Learners. So, this is the continued topic that we'll be having in our consideration today. Polynomials, power revision session 2. We'll be having one more revision session based on this, right? That is precisely more on factorization, but we'll be considering algebraic identities. So, in total, we'll be covering 8 such identities as per the curriculum. Let us get this started. And before we begin, if you are new to the session, new to the channel, please do subscribe the channel, do share it so that it can reach to optimum audience. And yes, this is how our roadmap is structured. So in this particular topic, we'll be having long division method and remainder theorem along with factor theorem. So remainder theorem, a part of it we have already seen in previous session, right? Now let us get this started. We need to consider an example. Suppose p of x, that is the denotation. That means it is representing a polynomial in x as a variable. It is a quadratic polynomial, x square minus 5x plus 6. It is divided by g of x, which is x minus 1. Find the remainder using long division method. So let us move to OneNote. So the polynomial stated there was x square minus 5x plus 6. That was p of x. And g of x was x minus 1. Right. We need to use long division method. So I'll be writing here long division method. That means x minus 1 should come here. All right. And x square minus 5x plus 6 is actually the dividend, right? And x minus 1 is the divisor. So we need to think of the very first term, which is x square. So by what term we should be multiplying it with so as to have x square? Obviously x when you can, actually have a rough work here. X when multiplied with x minus 1, you will be getting x square. This x is also getting multiplied to minus 1. So we'll be getting x square minus x, right? Whatever you got. Change the sign, right? Now this will go away. We have minus 4x plus minus 5x plus x will give you minus 4x plus 6 is to be copied down. Again, we need to think of a number. This is very first term. We need to think of a number which when multiplied with x minus 1 shall give us minus 4x. So we should multiply it with minus 4. But this minus 4 is also getting multiplied to this plus 1. Sorry, a minus 1. So it will be minus 4x plus 4. Right? Whatever you got here. It will be minus 4x plus 4. Subtraction is to be followed. So this will become positive. This will become negative. This will go away. And we have 2 as a remainder. So this is by long division method. We have calculated one remainder as such. Now we should be moving back to our slides and we shall see if suppose if some typical problem is given to us, how we'll be able to identify the remainder without long division method. So here comes the role of remainder theorem. So we can consider a similar example. In case if we want to calculate the remainder, then let us move to our OneNote first. But before then this, I just wanted to give you the very statement of remainder theorem. When p of x is divided by g of x, which is x minus a, then the remainder can be calculated directly by substituting the value of a in p of x, right? R equals p of a. Let us move to OneNote. Yes, so directly with the help of remainder theorem, we should get this calculated. Let us have a look here. So p of x was given to us as x square minus 5x plus 6 and g of x was x minus 1. In order to calculate the value of x from g of x, we can put x minus 1 equals 0. G of x can be equated to 0. In order to calculate the value of x comes out to be 1. Now this is something that we call value at a particular point in time, value at polynomial. So if we calculate p at 1, this will be 1 square minus 5 times 1 plus 6. So this will be 1 minus 5 plus 6. According to board mass, addition is to be done first. 7 minus 5, that is nothing but 2. Are we getting the same remainder that we got using long division method? Yes. So this verifies remainder theorem. Now, an extension to remainder theorem is, let us move to our slides. Factor theorem. What factor theorem is stating? Suppose by chance if we are getting remainder as 0, then we say that x minus a is actually a factor of p of x and p of x can be rewritten in this format, x minus a times q of x. Now what does this signify? Let us read the second statement as well. If x minus a is a factor of p of x, then p of x, when you substitute a instead of x, you will be getting p of a as 0, right? The value of that particular polynomial at that point in time will become 0 as the remainder is 0. Again, the statement remains the same. P of x equals x minus a times q of x. Let us move to our numerical example first. Now, if I'll be dividing 18 by 2, 18 by 2 can be written like this. We know that 9 times 18 we got, right? And the remainder comes out to be 0. Now, if I wish to express this in this format, dividend equals divisor into quotient plus remainder. Then dividend is 18, divisor is 2, quotient is 9, and remainder comes out to be 0, right? So if this part is 0, we can say that 18 is nothing but 2 into 9. That means if we divide 18 by 2, we'll be getting a perfect quotient, right, which is 9. And if we divide 18 by 9, we'll be getting a perfect quotient, which is 2. That means these two are the factors. Factors is anything, whatever we are taking into our kind consideration. If we divide that particular number with something and that number is completely divisible with that something, right, then we can say that that something is actually our factor. So 2 and 9 are the factors. So this is how the numerical explanation goes. Now let us consider a few examples based on this and on the problem statements. Example number 1 is x square minus 5x plus 6 is to be considered, and we need to find the factor using factor theorem. So let us move to whiteboard again. Now, in order to solve this type of question, x square minus 5x plus 6, let it be p of x. In order to solve this, we need to identify a point where this is becoming 0. We have studied 0 of a polynomial, so that will do using hit and trial methods. As g of x is not given to us, so we need to calculate g of x first. How we'll be calculating it? Let us have a look here. Whatever constant is given to you, factorize constant. Find the factors of constant. It can be 1, 2, 3, 6. Fine. Now, out of this, you can consider any particular value. So I am choosing 2. So if I'll substitute x as 2, let us see what we are going to get. It will be 2 square minus 5 times 2 plus 6. That means it will be 4 minus 10 plus 6. According to board math, addition is to be done first. So 10 minus 10 becomes 0. Bingo. That means at x equals 2, we are getting this particular expression as 0. That means x minus 2 comes out to be the factor, according to factor theorem. Second statement, right? Let me go back to the statement as again. See, if x minus a is a factor of p of x, that means at p a will be having the value of polynomial as 0. All right, so that is what our statement is. Now let us move to OneNote again. All right, so if x minus 2 comes out to be the factor of this, the highest power, that means the degree of p of x is what? 2. X square minus 5x plus 6. The degree is 2. That means we should be writing x minus 2 2 times with equal spaces. And here we need to have a big curly bracket. We need to have p of x structured here. How we'll be doing this? By what number or term we should be multiplying this x minus 2 so as to have x square? We should be multiplying it with x. So it will become x square. But this x is to be multiplied with this minus 2 as well. So it will become minus 2x. We need minus 5x. That means we need to have minus 3x here in x's, right? Two like terms can be added or subtracted. So if we are adding them, they are having the same sign. Then we'll be having minus 5x, right, into the picture. And our purpose is to have this particular bracket as p of x. So we need minus 3x here. That means now this particular bracket is gone. We need to use this bracket. All right. Whatever is inside this brackets, with the help of that, we need to have minus 3x. That means if I should be multiplying this with minus 3, I'll be getting minus 3x. But this minus 3 is also getting multiplied to minus 2. That means plus 6 is something that we'll be having. If you multiply minus 3 with minus 2, you'll be having plus 6. So last term is auto-adjusted. Now this is nothing but our p of x. But our important area is x times x minus 2 and okay, x times x minus 2 minus 3 x minus 2. Now if you are scanning it from left to right, x minus 2 is common, right? So it can be taken out as common. So we are having x minus 3. So this is how we have factorized a polynomial using factor theorem. Now let us move to the second point, we need to check whether x plus 2 is a factor of p of x. This is p of x. So let us write this in few steps. Let me have a white space. We need to check whether x plus 2 is a factor of, let us go back to our question, x cube plus 3x square plus 5x plus 6. X cube plus 3x square plus 5x plus 6. So this was actually our p of x, right? And this is g of x. We need to check whether this is actually a factor. Actually, you can, simply be considering this as, okay, you can consider this as g of x. Now, in order to have this using factor theorem, we simply put g of x equals 0 and calculate the value of x. So x comes out to be -2. Now, whatever the value that we got here, we need to substitute the value in p of x in order to calculate the remainder. So if we are, okay, let me rewrite this. It will be x cube plus 3x square plus 5x plus 6. All right. So we need to calculate the value. It will be p at -2 whole cube plus 3 times -2 square plus 5 times -2 plus 6. Now we need to check whether this comes out to be 0. If this is coming out to be 0, that means we can say that x plus 2 is a factor. We are getting a value of polynomial at x equals -2 as 0 according to factor theorem statement, right? Let us calculate the value. It will be -8 to -2 into -2 into -2. This will be 3 times 4 minus 10 plus 6 minus 8 plus 12 minus 10 plus 6. So we need to add first minus 8 minus 10. I am rearranging like terms plus 12 plus 6. So this will be minus 18 plus 18. Now if you perform this, you will have 0. That means at at x equals -2, we are getting p of x as 0. That means x plus 2 comes out to be the factor of p of x. Now let us see if we have anything else to be discussed. Yeah, nothing else. So thank you so much for your valuable time. Do share, comment, and subscribe if you are new to the channel. Thank you.